Good evening. So,
Good evening, sir.
good evening. So, any doubt up to what we have discussed? You have revised everything? So, whatever we have discussed, I told you that all that we are going to use, and today I will start from again from the Laurent series.
Hello.
From the Laurent series, yes?
सर होमवर्क आपने जो दिया था सर उसमें टेलर सीरीज कैसे लिखेंगे
हाँ हाँ
क्लियर नहीं हो पाया tan hyperbolic z का और ये लास्ट सेक्शन
तो लिखा नहीं टेलर सीरीज
हो नहीं पाया
है?
हो नहीं पाया कर नहीं पाया
किसी ने किया भाई? टेलर सीरीज
Yes, sir.
Yes, sir.
चलो वो एक बार आप पोस्ट कर देना ग्रुप पे, फिर अगर फिर भी नहीं समझ आएगा तो फिर मैं बता दूंगा, ठीक है? जिसने थोड़ा अच्छे से किया हो साफ हैंड राइटिंग में तो वो पोस्ट कर देना, ओके?
Okay, sir.
ओके। एंड अगर फिर भी समझ नहीं आता है तो आई विल डू दैट। ओके, सो लेट अस कैरी फॉरवर्ड द डिस्कशन ऑफ लॉरेंट सीरीज and it was like this: fz is equal to a naught plus a1 z minus z0 plus dash 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 plus b1 over z minus z0 plus b2 over z minus z0 square plus dash dash dash. Okay, this was our Laurent series, I told you. And using this Laurent series, I am going to discuss the concept of singularity. Okay, using that I am going to discuss with you the concept of singularity. Fine. So if only b1 is present, b1 is present, suppose you have a series, and in that series this is analytic part, so this will not play any role in the uh, singularity. This is non-analytic part, so this will play a role in singularity. So if only b1 is present, then z naught is a pole of order 1, okay, and known as simple pole, known as simple pole. So if only 1 over z minus z naught is present, that means b1 is present. So what is b1? It is coefficient of 1 upon z minus z naught. And suppose this dash 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 goes for up to bn over z minus z naught to the power n plus dash dash dash. So it is like this. So what is going to happen if bn is also present? bn is present, उससे पहले वाला प्रेजेंट है या नहीं है फर्क नहीं पड़ता, उसके बाद वाला नहीं होना चाहिए, ओके? So suppose bn is present, then what is the case? It is pole of order n. Then it is pole of order n. Okay, so there are multiple definitions of singularity. I am discussing them one by one. And C is if there are infinite terms of Bn, B1, B2, B3, B4, dash, dash, dash. There are infinite terms, then it is called essential singularity. Z0 is called, then it means Z0. Simple pole at Z0. All we are talking about Z0. Okay? So if there are infinite terms, we have essential singularities. That means Z0 is your essential singularity. And if we have finite number of terms, suppose it stops at B2, B3, B4, B5, anywhere. So if we have finite number of terms, then it is non-essential singularity. Okay? Non-essential singularity. Clear है यहाँ तक? Essential singularity, non-essential singularity. Then D. Suppose the singularity is Z0. Okay? Suppose Z0 is the singularity and I draw a very small circle of radius epsilon, where epsilon is very small, and no other singularity lies in this circle. No other singularity lies inside the circle. No other singularity lies inside the circle. Then Z0 is isolated singularity. Isolated singularity. And if other singularity also lies inside this, suppose Z0 was there and you have drawn a radius like this, but still, suppose Z0 is a singularity and still another singularity Z0 dash also lies inside that small circle, then it is non-isolated singularity. Non-isolated singularity. ठीक है? Is that clear up to this?
Sir, in the
तो
first
ये
one,
एसेंशियल वाला एक बार एक्सप्लेन कर दीजिए.
पढ़ो
Yes sir.
पढ़ो पढ़ो. If there are infinite terms,
Yes sir.
so that means this is dash dash dash.
Yes sir.
So there are infinite terms in Bn. So Z0 is essential singularity.
Okay sir.
It is written clearly. You read it once, you will understand.
sir, in the first one, if Bn is present, then Z0 is a pole of order 1. K by A, simple pole. K by A represents.
Known as yaar.
Okay.
Known as simple pole.
It is only if only Bn is present, then order n.
Bn is present, then order is n.
The only Bn or
Only or other, because order comes from the highest term. So doesn't matter कि before terms are present or not.
लास्ट वाला एक बार बताइए.
लास्ट वाला आइसोलेटेड सिंगुलरिटी है. तो जैसे मान लो ये पहले नोट कर लिया सबने, मैं हटाने आ रहा हूं ऊपर वाला. तो वैसे यहाँ जगह है थोड़ी सी, तब तक आप नोट कर लो, यहाँ डिस्कस कर लेते हैं. हाँ, दिस इज विजिबल ना, दिस पार्ट इज विजिबल.
Yes, sir.
Suppose this function is like this: fz is equal to 1 upon z minus 1 z minus 2. Okay, suppose this is the function. Okay, fz is equal to 1 upon z minus 1 z minus 2. So what are the poles? Z is equal to 1 and Z is equal to 2. These are the poles. Yes?
Yes, sir.
So if I make a small circle here of very small radius, then 2 will not come in this, na?
Yes, sir.
So 1 and 2 are what type of singularity?
Isolated.
Isolated. Isolated. Okay. And you know, they can be written like this also: a upon z minus 1 by partial fraction. Yes? So,
Yes, sir.
so z is equal to 1 is also a first order pole because only b1 is there, and z is equal to 2. So z is equal to 1 and 2 are first order poles also, na? By the first definition. Is that okay?
Yes, sir.
Tell me, this is clear?
Yes, sir.
So now let us take another example. I can erase this part now, no? You have already noted it down.
Please explain for non-isolated also.
Ha, obviously. So non-isolated is very specific. Okay. Very specific case like this. Fz is equal to 1 upon sine pi by z. Suppose it is like this. Okay. Now, what are the singularity? For singularity, denominator should become 0. So sine of pi by z will become sine of n pi. Yes? For poles, for singularity. For singularity. Are you understanding this? The denominator.
पोल्स और सिंगुलैरिटी एक ही बात है.
सिंगुलरिटी जनरल वर्ड है. सिंगुलरिटी के अंदर ही तो सारा पढ़ा रहा हूं. ओके. तो you can call pole as a type of singularity. Okay.
Yes, sir.
जैसे ऊपर लिख दिया तुमने कोई चीज, मान लो लिख दिया, और फिर नीचे उसकी वैरायटी डिस्कस कर रहे हो, इस टाइप की चीज है. ठीक है. So what will happen? Pi by z will become equal to n pi. At these points, the denominator will become 0. And what will be the value of z? 1 by n. So let me take z is equal to 0 is also there, but let us not consider that. 1, 1 by 2, 1 by 3, 1 by 4, dash, dash, dash. These are the points. Okay. Now you take, suppose this is 1. Okay. This is 1 by 2. Okay. This is 1 by 3. Yes. Is that fine?
Yes, sir.
Now, if I put a epsilon about, suppose 1 by 2. Okay. Hello.
Okay, sir.
Yes, sir.
So because if you take sufficiently small epsilon, very, very small, then also, because numbers are becoming smaller and smaller, you are free to take very, very small number. So numbers will come inside for sure. Even if you take very small epsilon about any number, the next number is going to come inside that. Are you getting this point or not?
Yes, sir. Getting this point.
Yes, sir.
Okay. So you can show this on number line and you can see for yourself that even if you take very, very small radius, and because I have liberty of taking numbers very, very small here, finally some numbers are going to fall into that epsilon radius. So that's why this is a very particular case of non-isolated singularity. Is that fine?
Yes.
So singularity means a point where the function is not defined. Okay. So in general, it is called singularity, but it has got particular names also. Like for example, first order singularity is also known as poles. Okay. So this I wanted to discuss with you. And now we will have to, write quickly Laurent series. We have to learn to write Laurent series very, very quickly, because this is independent question in your exam. And this is also a method to calculate singularity. You know that it is also a method to calculate the singular point. Okay. So let us write Laurent series for few questions I will take here. So let me take the first question. Fz is equal to 1 upon z
Not visible.
z minus 2. Okay. Suppose this is the function, and suppose the region is given 0 to mod z is less than 2. Suppose this is the region that is given, and we have to use this region to write the Laurent series expansion. Okay. We have to use this region to write the Laurent series expansion. Fine. So I told you that the only method is you can use Taylor series intelligently, or you can use binomial expansion. So you can see here that mod of z is less than 2. Okay. And also mod of z by 2 is less than 1. Is that okay? So fz is equal to, I have to use this z by 2 is equal to 1. So what I will do, you can see from here, I will take minus 2 common, and this will become 1 minus z by 2. Can you see that? And this will become minus 1 by 2z, 1 minus z by 2 to the power minus 1. Okay.
Yes, sir.
And now we can use binomial expansion. It will become minus 1 by 2z, and about, I am doing it about z naught is equal to 0. Okay, because nothing was given, and here it is mod z only. Mod z means mod z minus 0. Okay, it is like, you know, can we draw this region? How this region will look like? It is greater than 0. Mod z is radius, na? Mod z is radius of a circle whose center is 0. So it is greater than 0 means this is greater than 0, but less than 2, no? Suppose this radius is 2. So this whole region, this region is expressed by this. समझ आ रहा है ना?
Yes, sir.
So you use this binomial expansion 1 upon z by 2 plus z square by 4 plus z cube by 8 plus dash dash dash.
Sir, how is it minus 2z into 1 minus z by 2?
Sorry?
First step itself, f of z equal to 1 by minus 2z into 1 minus z by 2. How is it?
This step.
Yeah.
7th class mathematics. Take minus 2 common.
Oh, okay, sir.
Nothing is special. Why?
So can we write this in partial fractions? Would that make any difference?
So that will not be beneficial. You can do that. Then you will have to add it twice, na? Once.
So it is half of 1 upon z minus 2 minus 1 upon z.
Then you can expand that and then add both series, both one. Okay. So this will become minus 1 by 2z. Then what will be the value of this? Minus 1 by 4. Then minus 1 by 8z. Then minus 1 by 16 z square dash dash dash. This is the Laurent series. And let me tell you what is the value of B1. सभी लोग बताओ. Minus 1 by 2. And what type of pole is this? Simple pole. And also, what type of series is this? Essential or not essential?
Not essential.
Essential.
Not in infinite terms are not there, na? Only B1 is there. No other term is there in B. You don't recognize denominator. In denominator, the Z is coming only in the first term. No other term. Okay ना? एक क्वेश्चन समझ गए तो सब समझ गए. ये वाली बात होती है इसमें, तो इसलिए be very very careful about it. किसी को कोई डाउट है तो पूछ सकते हो.
No, sir.
What is the rule of 2 here?
Sorry?
So, why the mod is less than 2 is given in the...
Why? Why is no question. It is given. The region is defined. So we have to use it, na?
If it is not given, then what happens?
No, why it will not be given? If it is not given, how will you know that what is the value of Z? Then how you will open it using binomial?
Okay, sir.
Don't form. देखो, अगर आप क्वेश्चन फॉर्म करना चाहते हो तो आपको बहुत जानने, बहुत कुछ पता होना चाहिए. Otherwise, don't try to form a question.
सर पोल 0 पे होगा ना?
पोल तो 0 पे ही है. 0 के ही अबाउट मैंने किया है. पोल 2 पे भी है. बट ये इसकी वजह से mod z दिया हुआ था ना, तो it is what? Mod z minus 0 kind of given ना. Okay. So ये देखो मैंने लिख दिया है यहाँ पे, आप देख नहीं रहे हो ध्यान से. About z naught is equal to 0. Is that fine?
Sir, this if last term minus 1 by 2z, you told that this is b1. So b1 is minus 1 by 2. Minus 1 by 4, this is which term?
This is a0. This is a1. See the Laurent series, na, which I have given you.
Okay.
This is the constant term, that is a0. This is z minus z0 wala term, so that is a1. This is z minus z0 square term, so it is a2 dash 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 ho gaya. Here it is 1 upon z minus z0 term, so it is b1. See it carefully.
Excuse me, sir. Sir, when we solve this question by the method of binomial expansion, but when we solve by the Taylor series, then the answer gets same.
नहीं तो टेलर से इसको करने के लिए तुम्हें टेलर सीरीज को डायरेक्ट करोगे तो टेलर्स आ जाएगा ना, फिर लॉरेंट कहाँ रह जाएगा?
Need to solve the Laurent series, we can also use method.
That you will use very intelligently. I will tell you in some question. Okay, अभी उसकी बात मत करो. So please see this. Laurent series.
Sir, what if we need to find about z0 equals to 2?
Is opened.
Hello, sir.
About a singular point. ये बड़ा difference है. Okay. Laurent series is always opened about a singular point. आपने देखा कि Taylor series is purely analytic. Taylor series कैसी होती है? That is purely analytic, and Laurent series is opened about a singular point. So जैसे कि किसी ने कहा z0 is equal to 0, so what you will do? You will write a Laurent series, not a Taylor series. Okay? और जो मैं Taylor series कह रहा हूं कि हम use करेंगे, that I will tell you in some question how we use that. Okay? So can I erase this?
Yes, sir.
Somebody was asking in between.
Yes, sir, I was asking if we need to find out z equals to 2, z not equals to 2.
What?
If we need to find the pole about z not equals to 2 is question.
Yes, z is equal to 2 is also a pole. That is also a simple pole. Okay. So suppose nothing is given. Suppose the question is like this. And suppose we want to write the Laurent series about z is equal to 2. Z naught is equal to 2 because that is also a pole. Huh? So I will tell you the condition. What condition I have applied. So you need z minus 2 in the series. Huh? So what you will do is write z minus 2 is equal to t. Now the series of t will be Laurent series because z minus 2 will be appearing everywhere. So what will be the fz? 1 upon, what will be z? Tell me. T plus 2 and this will be t. Yes? And
Yes,
you take 2 common, it will become 1 upon 2t. And this side it will become 1 plus t by 2. Okay? Like this. And now
then we will take a coefficient over 1 upon t. Got it, sir.
I will write t by 2 less than 1. Huh? So fz will become 1 by 2t and 1 plus t by 2 to the power minus 1. And this will become 1 by 2t, 1 minus t by 2 plus t square by 4 minus t cube by 8 dash dash dash. Okay? The binomial expansion. So it will be 1 by 2t minus 1 by 4 and plus t square by 8 and minus dash dash dash. Okay, so replace t by what? Hmm?
Z minus 2.
So it will become 1 by 2 z minus 2 minus 1 by 4 plus z minus 2 square.
Only z minus 2, sir.
Okay.
8 equals z minus 2 only.
So what is b1 for this? 1 by 2. समझ आया? क्या कह रहे हो भाई? बी ओनली व्हाट?
Z minus 2 square is या z minus 2 आएगा.
t by 8 आएगा.
कहाँ पे? अच्छा ये.
Yes sir.
ठीक है, अगला टर्म स्क्वायर का होगा. ठीक है. समझ आ गया सबको? तो इसमें कंडीशन क्या है? t by 2, that means z minus 2 by 2 is actually less than 1. I have used this condition that mod of z minus 2 is less than 2. This should be given, then only I can expand this. समझ आया?
Yes sir.
Or if nothing is given, I will expand it like this and I will say that this is the condition. So now can I erase this? सबने नोट कर लिया होगा मेरे ख्याल से.
Yes sir.
Okay. So एक और क्वेश्चन बताता हूं. fz is equal to sin z over z to the power 5. Okay. I want to write Laurent series for this. You can clearly see that z is equal to 0 is a pole. Nah? So here I can use the Laurent series by writing the Taylor series because I know what is the expansion about z to the power 0 for z minus dash 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 over z to the power 5. So I will write one more z to the power 7 by 7 factorial plus dash dash dash. Can you see that? So sin z by z to the power 5 was there. Immediately I saw that the denominator, by putting denominator is equal to 0, z is equal to 0 is a singular point. And then I also know the expansion of sin z about z is equal to 0. That is the Taylor series. So इस तरह से मैंने Taylor series का use कर लिया and I will get fz is equal to, बोलो भाई, 1 by z to the power 4 minus 1 upon
6z square.
3 factorial plus 1 upon 5 factorial minus z square by 7 factorial plus dash dash dash. So what is B1?
Zero.
Okay, so this is also a Laurent series and only two terms are there. And what is the pole? Z is equal to 0. And what is its order?
4.
Fourth order. It is a fourth order pole. Okay. समझ आ रहा है सबको भाई?
ओके सर। हाँ।
So these are the methods to calculate and we'll be getting many of them while calculation. एक
Sir,
और
B4 is also there, right? Sir, B4 is also there. Coefficient of 1 upon z की power 4.
तो उसका क्या करोगे?
So why we have not taken that?
So you know I have already told you why B1 is special.
Okay, sir.
You want to name it, you name it. You want to name B2 also, it's fine. Nobody can stop you. But why B1 is important?
Highest to the
Huh? Sorry?
The residue.
Sir,
Why?
higher term उस तरफ होगी. Everybody will, other terms will be inside the circle.
आप क्लास नहीं अटेंड कर रहे हो क्या? कल की क्लास आपने अटेंड करी थी?
सर नेटवर्क इश्यूज था तो
अब यार
नोट्स छूट गए थे. आई हैव टू रिवाइज.
ये अब इसका तो कुछ कह ही नहीं सकते. मैंने बताया कि काहे B1 इंपॉर्टेंट है क्योंकि ये रेसिड्यू है और इसको हम आगे इंटीग्रेशन कैलकुलेट करने में यूज करेंगे. तो इसलिए मैं बार बार B1 लिख रहा हूं बिकॉज दिस इज रेसिड्यू. इसका नाम क्या है? अलग से इसका नाम रख दिया गया है रेसिड्यू. ओके
सर फोर्थ ऑर्डर क्यों रखे हैं?
क्योंकि मैक्सिमम z टू द पावर 4 है डिनोमिनेटर में.
ओके सर.
तो क्या लिखें तुम बता दो.
ओके सर. ओके सर.
ठीक है, हम तो आप ही के हिसाब से चल रहे हैं भाई. आप अगर कह दो तो इसको फिफ्थ ऑर्डर लिख दूं, जैसे कि यहां देखने में लग रहा था ना, बट ये था नहीं. कितने ऑर्डर का था? फोर्थ ऑर्डर का. चलो आगे बढ़े भाई, हटाऊं इसको?
यस सर.
चलो एक और बता देता हूं टेलर सीरीज का यूज. दैट इज fz इज इक्वल टू, जो मैं कह रहा था ना इंटेलिजेंटली यूज करना है टेलर सीरीज को. ये नहीं है कि सीधा टेलर सीरीज लिख दिया. अपॉन z माइनस पाई बाई 4 टू द पावर 3. अब बताओ व्हाट इज द पोल? पोल क्या है?
पाई बाय 4.
Pi by
पाई बाई 4.
पाई बाई 4. और ऊपर है साइन z. तो क्या किया जाए? मैंने आपको भी बताया है तरीका कि z माइनस पाई बाई 4 को क्या लिख लें? t लिख. तो ये हो जाएगा f ऑफ z इज इक्वल टू साइन t प्लस पाई बाई 4. यस, over t cube. Yes, so this will be sin a cos b, इसको 1 by root 2 को कॉमन ले लेते हैं, प्लस cos a sin a cos b, cos a sin b. 1 by root 2 will be common. What happened भाई? आजी को क्या लिख रहे हो? ये क्या लिख रहे हो यार? कौन सी भाषा है? यामिन,
ये मिस्टेक हो गया, व्हाट्सएप का रिप्लाई यहाँ पे चला गया.
so this will be 1 by root 2. and what is the expansion of sin t? आप जरा ध्यान से देखो, कॉम्प्लेक्स में बिल्कुल एक्सपर्ट बन जाओगे. what is sin t? t minus t cube by 3 factorial plus t to the power 5 by 5 factorial plus 1 minus t square by 2 factorial plus t to the power 4 by 4 factorial dash 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 over t cube. यही है ना? देखो कहीं गलती तो नहीं हो रही कोई?
Right, sir.
And what is b1? Tell me.
1 by 4 factorial.
ना, minus
Minus 1 by 2 factorial.
minus
1
1
by
upon
2
2
root
root
2.
2.
दो बार में भी आपने गलत बताया भाई. देखो यहाँ t क्यूब है, यहाँ t स्क्वायर है, तो सिर्फ एक ही टर्म है जिससे 1 upon t मिलने वाला है. Only one term is going to give you 1 upon t. And what is its coefficient? Here it is 1 by 2 factorial and root 2 is outside. So you will get minus 1 by 2 root 2. समझ आया?
Yes, sir.
ध्यान से देख लो, कोई डाउट है तो बताओ.
Sir, in this problem, can we expand sinusoid about pi by 4 and then do?
Yes, that you can do.
Thank you, sir.
But आपको ये आइडिया नहीं अच्छा लगा?
अच्छा लगा, sir.
तो वो सीखने की कोशिश करो, अपने तरफ से करने वाला बाद में देख लेना. जो अभी सिखा रहे हैं ना, try to learn that. You should be adaptive to new methods. If you learn something new, try to adopt that. So the story of Laurent series ends here, and the purpose of teaching you Laurent series is twofold. One is because direct question many times has been asked that what is Laurent series for this in this given region about this point. This is very popular question. And second important thing is that we are interested in residue. Residue will be used to calculate the integrations. So that's why also Laurent series is important to us. Okay. So now let us come to the residue. Why that is important? I told you that if I have an integral fz dz, this is a closed contour. This sign is for closed. C is contour. So that is equal to 2 pi I sum of residue. ये मैंने बताया था. This is Cauchy integral formula. इसका क्या नाम है? Cauchy integral formula. So for every fz, there will be a need of calculation of residue. Can you see that? So we should be knowing how to calculate residue. So it is very important. We should learn the calculation of residues. We should learn the calculation of residues. Okay. The first method is that I have already told you. B1 of Laurent series. ये आप सीख चुके हो ना? Calculation. Second method, nth order pole के लिए पहले सिखा रहा हूं. If the pole is of nth order pole, please see this. So the residue is given by limit z tending towards z0 1 upon n minus 1 factorial dn minus 1 over dzn minus 1 z minus z naught to the power n fz. देखो समझ आ रहा है आपको?
Yes, sir.
If we can calculate this, value, that is going to give me the residue at nth order pole. Okay. Now the third one is a special case of this. Simple pole. That means n is equal to 1. Yes. तो क्या हो जाएगा? It will become limit z tending towards z0. So if you put n is equal to 1, that means no derivative. Z minus z0 f of z. This is the simple pole, And I must tell you, this will be used very, very much. Residue at simple pole. And fourth case, phi z by psi z. Phi z by psi z. If your function is of this form, numerator over denominator, then the residue is given by limit z tending towards z0 phi z by psi dash z. And obviously psi dash z naught should not be equal to 0. Otherwise it will become infinite. Psi dash z naught should not be equal to 0. Okay. Check this before applying this method. और ये ज्यादातर लगेगा complicated equations में, transcendental equations में, I mean equation containing hyperbolics, exponential, etc. Okay, complicated equations, transcendental equations. So these are the methods to calculate residue. We will be using each one of them one by one patiently. And because if you want to learn how to calculate contour integration, if you want to learn the method to calculate contour integration, the only way is through residues. So the very first thing is that we should be knowing how to calculate the residues. और मैं अलग से रेसिड्यू नहीं सिखाऊंगा आपको, क्योंकि वो तो वेस्टेज ऑफ टाइम होगा. मैं इंटीग्रेशन से रेसिड्यू सिखाऊंगा, बिकॉज हर इंटीग्रेशन में रेसिड्यू आने वाला है. सो बेटर इज वी शुड स्पेंड टाइम ऑन इंटीग्रेशन, and every integration we will have to calculate the residues, so that we will do lot of questions on residues. If there is any doubt up to this, please ask. Clear है?
Yes, sir.
Okay. So let me give you one example, and we'll be doing a lot of questions, I told you. But let us start. The speed of teaching is okay, na? It's not. You're
Yes, sir.
following?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
Okay. So let us take a question, this tan z. Okay. And suppose we have to calculate residue at the poles. So what are the poles? Let us write the poles. Fz will become sin z by cos z. Yes. It is like this. And if cos z becomes 0, so let us, there will be many poles, but let us write one pole. So z is equal to pi by 2 is a pole or not?
Yes, sir.
Yes, sir.
Yes, it is a pole. So what will be the residue? Residue will be limit z tending towards pi by 2 sin z upon derivative of this will be minus sin z. Yes. What will be the derivative of cos z? I told you the method, na? Sin z by phi z by psi dash z. देखो जरा last वाला method.
Yes, sir.
So what is the value? Anybody can tell?
-1.
-1 is the answer. -1 is the residue. तो ये देखो एक क्वेश्चन मैंने आपको समझा दिया. कौन से वाले केस का? phi z by psi dash z, limit z tending towards z naught. क्लियर है?
Yes, sir.
चलो फिर हम लोग कल मिलते हैं and then we will take this discussion further. If you have any doubt, I can give you some time. You can ask.
Excuse me, sir.
हाँ बोलो.
Sir, what is the expansion of f of z is equal to 1 over 1 minus z by using Taylor series?
This one.
Yes, sir.
About z is equal to?
Iota.
तो iota तो I told you ना.
Sir, you told by the binomial expansion.
अरे
But
तो
I am
that will be same भाई. That will not be different. I told you by binomial, you calculate it by formula. Taylor series is unique, na? You will get the same value.
Okay, sir.
So why you are asking that do it by Taylor's method? You do it by Taylor's method, you will get the same answer.
Okay, sir.
तो आप calculate करो f z naught, f dash z naught, f double dash z naught. Derivative ही तो करना है और value put करनी है. You will get the coefficients. और मैंने बाइनोमियल से कराया, मैच कर लेना आंसर. ठीक है? ओके, थैंक यू.
सर
हाँ बोलो बोलो.
सर एक से ज्यादा रेसिड्यू हो सकता है क्या इक्वेशन के लिए?
Yes. If there are two different poles, there will be two different residues.
Oh, then we'll have to take sum of residues.
No. You don't have to.
Sir, but in that equation we had to take sum of residues, huh?
In which?
Contour integration equation.
So are you talking about contour integration or are you talking about residue? You are talking about residue with me.
Sir, 2 pi I into sum of.
So that is something different, na?
Okay.
You are talking about residue.
Sir, isn't the sum of residue in that residues?
There it is sum of residue, but that has not come till now. Na? I will discuss that once it comes. Right now, only I am discussing the residue. So if you have two different poles, you will get two corresponding different residues.
Okay, sir.
That will be summed for integration. It is an entirely different story, na? But somebody asks you, what is residue for these two poles Z0 and Z0 dash? So what you will do? You will sum it up. No, you will tell that corresponding to Z0, the residue is this, and corresponding to Z0 dash, the residue is this. Okay.
Sir, if you don't mind, I say few words towards your class. Hello, sir.
Tell.
Sir, first thing, your teaching style is provides the clarity in physics. From your side, you try to collaborate the students and find their mistakes. Tell them where they are exist and exist. We ask so many questions from you, and you tell that your basic concepts are so weak. we learn so many things from you, and we learn one thing from you ki, if you can't do the practice and you can't concentrate in your classes, you can't go and perform in CSR net. And sir, we so many coaching institutes are going on, but your platform is providing COVID-19 so good, many things we learn from you.
Okay, so is that appreciation? Thank you so much.
Sir, not with appreciation, because we are physics student and you try to give such type of platform, because those students are not came at Delhi. They so this thing is so good for those students.
See, only see our coming into this profession is just out of you can say our hobby, or we like teaching physics, huh?
Yes,
So
sir.
whatever are your doubts you can ask, and if I answer them rudely, that means you have to be very, very careful. The only purpose is that
Because sir, basically
the time should
yes,
not be, time of other students should not be wasted, number one.
yes,
Because
sir.
we should not ask those questions which will waste time of others, but still you can ask quickly. But if teacher gave you a symbol that let us not waste time of others, you can WhatsApp or you can ask in that question other ways.
You sir,
And
basically this.
whatever we are doing in class, please revise it.
Yes, sir.
Revision is the key to success. The only way to succeed is by revision. Okay, because the question we select is very particular, that gives you some insight about the problem. So please revise that question and then come with doubts if you have any. Okay, so abhi to bahut abhi the course has just started. A lot of
Sir, but first thing is so good na ki we just find this environment in IIT Foundation. But I so appreciated that ki we are doing the IIT Foundation course, and now I joined this platform because I follow this platform last 3 years. But due to the family problems, I can't come Delhi to prepare this.
I can understand. Okay, so just let us make it a
It's not-
better.
yes, sir,
better.
it's-
And online teaching is a two-way. It's from student side also. We need support, because without your support, the class will not go smoothly. Okay, so your support is also important, and we will try to do our best, whatever best can be done. Okay. Okay, thank you so much. Thanks for your nice words, huh? Thank you.
Thank you,
Okay, sir.
sir.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.